Hello everybody. So today we will create this animated maze generator in JavaScript. Now in the last video we have created another one, and compared to this one you see there are a few key differences. The first difference is this is animating. So we can see that how it is finding that where the maze should be. On the other hand, here everything is like pre-generated. So we will get a better idea of how the algorithm is actually creating the maze. And there is one more difference, and this is more subtle, and that is here we have thick walls, whereas here we have thin walls. So here every cell is a path, but we cannot go from any cell to any adjacent cell because there are walls. And so this is what we will build today, and let's see how we can do this. Now in my VS Code, I have some minimal HTML and some styles. And I will quickly go to my script.js file, which is empty right now. And I will start by defining my canvas. So canvas equals to document.querySelector canvas. And then we'll define the context equals to canvas.getContext context 2D. And if we go to our browser, this is how it looks like right now. So next we need to define our cell size and other dimensions. So let's start by doing that. So we'll define the cell size to be 25. And so how many rows and columns do we have? So the rows will be canvas.width divided by the cell size. And the calls or columns will be the canvas.height divided by the cell size. We are not defining it directly because we have already defined the width and height of the canvas to be 500. So this is like 2020. Now next, we need to define a maze. The maze this time will not be as simple as the last maze. It's a little bit more complex, and we'll see why is it so. And we will also have an ID every time we are generating a maze. So consider this is generate ID. Now we will also define some colors, and let's define a background color. Let's name it BG as white, and a wall color um, to be black. Now what do we need to do? So we need to generate our maze, and to generate our maze, so let's write a function called generate maze. And this function will also be called whenever we are clicking on the generate btn. So here, let me also create a generate btn equals to document.get element by id generate btn. And before or after the generate maze, we will do a generate btn dot add event listener. Click. Whenever we are clicking, we should generate the maze. Now we need to define a function called generate maze. It's a no-brainer. And inside the generate maze, as we can see right now, we don't have a maze. So to generate a maze, we need to define some initial maze. So inside I will call another function. It's called init maze. And hence I have to define another function called init maze. Now, how can we define a maze is what we will see now. So whenever we are creating a maze, we are basically defining like which cells have which walls or not, etc., etc. And to do that, we will need another array. We'll name it visited array. So let's define another variable called visited cells or array or whatever. So this array will basically keep track of which of the cells we have already visited. So this will be array of rows dot fill. So we have all the rows now. Now every row we will fill with array of calls. So array calls dot fill false. So initially there will be a lot of false, which means none of the cells are actually visited. So console log, let me log the visited cells. Let's take a look, and we have 20 cross 20 and every value is false, which means nothing is visited. Now we don't see anything right now because we are not yet drawing the cells, but we will do it soon, and hence we will see it soon. So now inside my init maze, what we need to do. So we have already defined the maze to be an empty array. So let's also assign the value once again. And here we need to create some loops. So we'll take I from 0 to rows, that is 20. Now here, all the visited cells of I we will fill with false. And then let me define a row, an empty row. Now we have to look through the columns also. So for j equals to 0, j is less than false, and j plus plus. And here, for every row, we need to push a certain value. So what we will push? So for every row, we are basically looping through 20 times because there are 20 columns. So we'll basically push the value of each cell. So each cell will have an x. The x value is j, and then we'll have a y. The y value is I, and then we need to define that the current cell has how many walls. So there can be walls in 4 directions, and we will define by 4 values. Consider we have walls in every side. So true, 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 and true. Consider this as the north, south, east, and west walls. And then inside the inside my maze, I want to push my row. And now if we log our maze once again, what do we see? So for our maze also, we have lots of interesting values. So all the walls will be basically true, 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 and x and y values are different. So the x and y values will basically loop through all the cells of the maze. Also, one more thing is if we log the visited cells here. So we have already logged the visited cells once, and we are doing it again. Let me remove the console of maze. And here, regarding our visited cells, what do we get? We are basically getting the same values as the first one, but we are doing it twice. And why is that? The reason is simple. In our last maze, we had a like very minor issue, and that is whenever we are clicking on the generate button, the new maze was not generating, and we fixed that by assigning by basically reinitializing the maze, and that is exactly what we are doing here. So in case we are not doing this line, it will only take the initial visited cells, and after all the cells have been visited, it is not getting refreshed, and hence we will not be able to generate the new maze. There will be problems there. And to take care of that, we have to assign the visited cells with false. Basically, every time we are calling the generate maze, and hence we are also calling the init maze. Anyway, so that is all we need to do for our init maze. Now next, what do we need to do? We remember there is a generate ID. So whenever we are generating a new maze, we will basically add our ID. So let me name it cur generation ID is basically my generate ID plus 1. So every time we are clicking on the button, this ID will keep on adding. But whenever we are refreshing the page, it will once again start from 0. And this is actually important to keep track of which is our current generation. Now, inside my generate maze, we need to keep track of which sales we are visiting and which sales we are not visiting at the moment. And we will keep track of that inside a stack. So let me just create an empty stack. And let's also create a start x and a start y value. So you may remember in the last video, we have taken both the start x and y to be 1. But I have told that we can actually start it from anywhere. And that is what we are doing today. So what we will do is it will be anywhere in between, let's say 0 and 20. So what I will do is we'll take a math.floor and a math.random times my rows. And for the next one, math.floor and a math.random times my calls for our start by. Basically a value between 0 and 19. And next, what we need to do is since we are starting at x and y, the x and y value should be true. So start y and start x, this value should be true. And hence, we will push the same value to our stack. So stack.push, we will push, for the x, we'll push the start x, and for the y, we'll push the start y. Now, let's try to make things a little bit interesting and let's try to draw our maze. So right now, we only have one visited cell and other cells are not visited. So if we draw the maze at this moment, how will it look like? So I have created a draw maze function like I'm calling, and now I'm creating. Now inside the draw maze, what do we need to do? We need to draw. So let's see how we can draw. So first things first, we'll do a cityx.fill style. This will be our colors.bg, basically our white. And then we need to fill the rect, and let's fill the rect with the white. So from 0, 0 to canvas width and canvas height. You can also consider this to be clearing of the canvas. Now for drawing the cells, we need to loop through our rows and columns once again. So I equals to 0, I should be less than rows, and I plus plus, and same goes for our j equals to 0, j is less than false, and j plus plus. Now inside, what we will do basically is draw our walls. And so let me define a cell as maze of ij. Now we need to define the absolute values of x and y to draw our walls. So the value of x will be j times the cell size, and for the y will be I times the cell size. So in case the index is, let's say, 4 comma 6, the absolute values will be 100 comma 150, and that is the place where we want to basically draw our walls. Now our walls are basically lines, so let me again give a stroke style as colors comma wall, and then we'll give a ctx dot line width to be 2. Now we have 4 walls, and what we have to do is basically check if the walls exist or not. So we'll check like this. So if the value is true, we will draw our walls. Otherwise, we will not draw. And we will check by cell comma walls 0, 1, 2, 3, like that. And inside drawing our wall is very simple. We have to do ctx.begin path, then move to our basically x comma y, then ctx.line to our x plus cell size comma y, and then ctx.stroke. This is basically our top wall. So if we take a look, we have all the top walls. Now the value is true, so we are basically getting it. Now after this, we will draw the next wall, which is our right wall. So here we will once again go to xy. Now instead of xy, we'll go to x plus cell size, and we'll draw the wall up to x plus cell size plus comma y plus cell size. And this is what we are getting. So this is our all of our right walls. Now similarly, we have to draw our left walls and our bottom wall. So let me once again copy these two things. This will be 2 and 3. And so once again, we will go to x plus cell size, comma y plus cell size, and the move will be this. And for the last one, x value will remain as it is. We'll go to we'll go to xy, and we'll draw up to y plus cell size. Yeah, so it will look just the same. The only thing is we are drawing walls in every direction. So the only way to understand that this is working is if we make 3 of the values as false. So we are making all 3 as false. Now as we can see, these are all the left walls. Now let's make this also false. Now we have no walls. If I make this value as true, then we have all the bottom walls. So initially all of our values will be true, and then accordingly we will create walls, like we will create entrances within the walls, you can say like that. So this is more like a maze where you enter a room and there are lots of doors or kind of doors. So some of the doors will open, the other doors will not open, and hence you can find a maze kind of thing. And yeah, you have to find an exit or something like that. So this is very similar to one Pokemon episode that I remember is of the Trick Master. So the Trick Master used to make worlds like this, where some of the doors will open, some will not open, and you basically have to find your way through it. Yeah, so something like that. So yeah, so our walls are done, and it really doesn't look that much interesting right now. Now, one more thing we need to take care of is our visited. So, for example, we have a start x and y value. We don't know which value is this one, but we can check it by drawing that cell with a different color. So, we'll do that if visited cells of ij, if this value is true, then we will paint it differently. So, what we'll do is ctx dot stroke style, not stroke style, this will be a fill style equals to what I will do is let me add another color in the colors, and that is visited. This will be orange. And here we will do colors dot visited, and then ctx dot fill rect will give the xy cell size and cell size. Yes. So now we have an idea that which is our visited cell, like which is the starting cell. Now we are clicking on the generate new maze. Nothing seems to work. And why is that? Okay, this is a new one. I think so. This one, let's refresh. It is not working for some reason. Let's come down. Okay, I think there is an issue here. Now, whenever we are clicking on the generate maze, a new maze should come about, and this should work. Yes. So as we can see, every time we are starting with a different cell. Now, ideally, if this is a maze, it should only be in the corners. But yeah, anyway, I think that will be a minor fix. We can do that later. Now we need to see that how we can explore the maze. Yeah, that is the main part. So our drawing is more or less done. There is nothing more that we need to do here. And so let me just minimize our draw maze. So what we need to do is inside my generate maze, we have to find new ways. So how can we do that? So whenever we have some values in our stack, we need to check if our stack dot length is more than 0. And we also have to check one more thing, and that is if the current generation ID equals to our basically generate ID. Now you may wonder that this will always be the same because we are assigning it like this, but it will not be same if this is an async function. And this will be an async function. Yeah, but we will see that soon, not right now. So inside my while loop, I need to check few things. First thing is that what is the current cell that we are in? And this is basically our last value of my stack. So stack.length -1. So this is the current cell. And now we need to find the neighbors of our cell, especially the unvisited neighbors. So let me write a function unvisited neighbors, and we will pass the current dot x and the current dot y, and we will also pass all the visited cells. Now we have to define another function called unvisited neighbors. So function unvisited neighbors, and inside we have to pass all of these things. So basically our x, our y, and our visited cells. Now inside the unvisited neighbors, what we need to do is first of all create a neighbors array as an empty array. Now let's take some directions. So directions, this is something that we have done in the last maze also, you might remember. But in this maze, we will only take like the adjacent cells. We will not check two adjacent cells because it doesn't have walls, like thick walls. It has thin walls. So this will be good enough. So we are checking the top one, then we are checking the right one. Y will be 0, then x 0, y 1. This is basically our bottom one. And then finally, we have x as -1 and y as 0. This is basically our left. So we have 4 directions. Now for every direction, so directions dot for each. For every direction, we will have a current direction. So let me name it as curdir. Now here, we will have a new value of x and a new value of y. So this is basically our x plus curdir x, and our new y will be our y plus our curdir dot y. Now this is a very simple check that we need to do. We need to check that if the new x, new and y values are inside the bounds. That is, if the x value is not -1 or more than 20, those things. Very simple checks we need to do. So new x should be greater than equal to 0 and new x should also be less than false, basically 20. And similarly for the new y should be greater than equal to 0 and new y should be less than rows. And finally, one very important thing, and that is the visited cells of the new y, new x, this should not be visited. So the value should be false. And only then we can call it an unvisited neighbor. Otherwise, we will not be able to call that. And hence, we will push neighbors.push will push the value of new x in x and new y in y. And we will lastly return our neighbors. So return neighbors. So what we will get here is we will get some neighbors. Now, if you observe carefully, this becomes an infinite loop because although we have some neighbors, the stack value is not really changing. So the while loop will keep on running. So we have to do something about this situation. So what we will do is we will check if neighbors.length, if this becomes 0, then we want to pop our stack. So what this means is that we have no neighbor or all of our neighbors are visited because we are actually getting all of our unvisited neighbors. So if that is the case, we will pop our stack and possibly we will get out of the while loop. But this only solves half of the problem because we are not really changing anything in our stack. So our stack value will always contain the current one, and that is the only value it will have, and the while loop will keep on running. So what we have to do is we have to pick one of our neighbors randomly to visit. We have to mark that cell as visited, and we have to keep on doing it. And in this way, many of our cells will be visited, and a time will come when all of our like neighbors will be visited, and this value will be 0, and we will pop our stack and finally get out of this loop. So to simplify, what we are doing is we are picking a next cell to visit, and this will be randomly picked from our neighbors. So neighbors and math.floor math.random times the neighbors.length. Now then, what we have to do is we have to make the cell as visited. So visited cells next.y next.x, this should be true, and we also have to push the next value into our stack. So now our stack has basically two cells. So the next time the current cell will be this next cell, and so on and so on. It will keep on going, and we will have to draw the maze once again. But this will not really change anything because inside our draw maze, what we are drawing is basically we are drawing all of our walls, right? Now, what we have to do here is do something like this. We have to remove the walls between our current and our next cell. Basically, wherever the wall value is set to true, we have to make it false. So I will, so where is our function once again? Yeah, so what I will do is I will call another function called remove walls between our current and our next. And this will basically remove the wall between these two cells. Now I have to create this function now. So function remove walls, and it will contain two neighboring cells. Let's call it A and B for simplicity. Anyway, these are neighboring cells, and this could be any neighboring cells. Now let's take the dx value as a dot x minus b dot x. Basically, the difference between the x value of the A and B. And similarly, we will get a dy value a dot y minus b dot y. Now, why are we taking these values? Because if the value of dx equals to 1, in that case, we have an idea that which wall is this. So for our maze, AYAX, This is basically our wall number 3. I believe that is the left wall, and hence it will be the wall number 1 for our Vy and Dx. On the other hand, if the Dx value, so we have to write else if the Dx value is -1. In that case, for our maze AyAx, basically this will be flipped. So for the first one, this will be the wall number 1, and for the second one, this will be the wall number 3. Now we also have to check the dy. So if the dy equals to 1, for the first one, it will be the wall number 2, I believe. Not 2, but for the first one, it will be 0. And for the second one, it will be 2. Basically the top and bottom. So one for the top, the other for the bottom. Else if dy equals to -1, in this case, basically this will be flipped once again. So for this, it will be 2, and for the b1, it will be 0. And once we have changed all of these things, our loop will work well. Now let's go back and let's refresh. We don't really see much changes. Let's try to get our neighbors and see things are working fine or no. So below our neighbors, let me try to get my neighbors. And we are not getting anything. Why is that the case? Above the while loop, let me print the stack, the current generation ID, and the generate ID to understand what's really going on over here. So this is the problem. There is a difference between our current generation ID and our generation ID. So these two values are not the same. Must be some weird behavior of JavaScript. Now we have to have this, but for the time being, for a test, we can just remove this one, and we can only run the loop on the length of the stack. So now, as you can see, we have an interesting maze. We can click on generate new maze, and the maze is also changing. So we already have a very interesting line maze that is also generating on click of this button. Now we don't really want to generate it like this. We want to animate and try to understand how it is coming up with this maze. And to do that, we have to use some of the async features of JavaScript. Doing that is not at all complex. We have to make this function generate maze an async function. And if you come down, we are calling to draw maze. I think that is why there was some slowness. Anyway, after our draw maze, we have to call a delay function, and we'll delay by 100 milliseconds, let's say. And we have to create the delay function. So async function delay will have some milliseconds and will return new promise resolve. And we want to do a set timeout of resolve and the millisecond, which is basically our 100 milliseconds. Now if we go back, we can see that we can see our maze generation live. Now I think this is too slow. You can also make it fast by making it 50 instead of 100, or much faster also. So let's make it 50 and let's see. So yes, so we have a maze generation going on. Now if we click on generate new maze, there is some weird results happening. So there are 3 mazes that is generating simultaneously. And this is because of the maze ID. So why we were taking care of that, taking care of the ID, is because we don't want to have this. So whenever the current generation ID is same as the generate ID, basically whenever we are clicking on this button, the generate ID will increase, but the current ID will remain the same. So basically at a time we will only have one. So we have to add this one. So whenever this current generation ID equals to the generate ID, only then you will do this. So now if we come back and generate, there is some issues happening, and let's try to understand why is that issue coming. So our current generation ID is 1, generate ID is 0, and we can avoid it by using the unary operator. And yes, so now if I click on generate new maze, as you can see, we have a very interesting maze generation going on. Now we will also do this thing in Godot. It's very interesting, and we can also randomly generate caves and dungeons to create our RPG games, and that will be very interesting in Godot. Now there is also one more thing that we need to see, either in Godot or in JS, but that is also a very interesting concept, and that is how a player can move through this maze. So we are generating a maze, but using backtracking algorithm, how one player can find an apple or a coin or a hidden door somewhere in the maze. That is also a very interesting case, and we will also see it very soon. Now, that's it for this video, folks. Now, if you have learned something new in this video, make sure to give this video a like and also subscribe the channel to help me grow it fast. And I will see you soon with another very interesting video. So, see ya.